99% of the time, the Earth is basically still, and we get very accustomed to that.
A powerful earthquake rattled central Oklahoma Saturday.
A magnitude 5.6 earthquake northeast of Oklahoma City.
This is surveillance video from inside the store. It captured glass shattering on the ground.
I grew up in Minnesota. We'd take trips out west, and we saw the mountains and the folded rocks. And it was fascinating to me that rocks could fold and bend and form mountains and move, because the Earth really does seem pretty still for most people, for the most part. I realized I liked math a lot, and I liked to be outside, so I went for geophysics, because I could combine basically being outside and doing math. I loved it because I actually feel like it's a puzzle we can never fully solve. There's so much about the Earth that we don't understand. I mean, it has impact from water resources to hazards to, energy, oil and gas resources. The practical aspects are there, but it's also just this challenge that I can stick with my whole life, and it doesn't get boring. Earthquakes, if you've been in them, it can be a really dramatic jolt. Sometimes it can be just sort of some wavy kind of movement, but at other times it's really intense, really fast, and shocking.
And there it is on the map, the magnitude 6.0 quake hitting just north of San Francisco. And look at this surveillance video. Cameras rolling.
Usually we think of earthquakes in California, in Alaska. There started to be earthquakes where historically there hadn't been.
This morning's earthquake was centered right around Cherokee, Oklahoma. It was a 4.7 in magnitude.
And so it was a puzzle as to why this was happening. I was in Oklahoma at the time, and I was oddly or fortuitously well placed to be able to understand the earthquakes. The earthquakes geographically spread through time until it encompassed the suburbs of Oklahoma City. That potentially brought it home that this is real, this is serious, it's not going away. Let's look at the science, let's decide what we're going to do.
Earthquakes rattling Oklahoma over the past few days. The Geological Survey says about 700 strong earthquakes have hit Oklahoma so far this year. That's way up from just 20 in 2009.
My expertise in general is high-resolution imaging of faults and seismicity. There weren't many people in the area that had the background necessary to understand the problem. The very first step was to record the earthquakes better. And so we put out stations, went out into the field, and then we started to get all of the data that we could on wells, where the water was going in, what rates, and tied that all together with physical models of how that fluid would move through the subsurface to see if you would be raising pressure at the earthquake locations from these wells.
Cornell University seismologist Katie Keranen was teaching in Oklahoma when the increase in quakes began. Keranen was among the first scientists to link the earthquakes to oil and gas production.
These are man-made earthquakes.
Most people feel that the majority of these are linked to this water being disposed. Fracking and the injection are not actually one and the same. Basically, fracking is part of the production process, and the water disposal that's causing the earthquakes, at least in Oklahoma for the most part, is a byproduct of getting rid of what's happened from production. So it's not actually the drilling, but once you drill, they were producing a lot of water. Then you have to do something with the water, and so they were injecting it back into some other part of the subsurface. And then when that pressure rises against a fault, you can basically trigger the fault to slip, and that's an earthquake. That's where the earthquakes come from. My approach was really just to keep it focused on, do we understand physically what's happening? What do we know, what don't we know, and what can we say with certainty? To help the rest of the people that were interested decide what to do after that.
Studies are linking the injection of wastewater for enhanced oil and gas exploration.
And so there was that process of years of many others doing research that corroborated the research until now, when in Oklahoma the governor has sort of acknowledged that these are induced, and the Corporation Commission, which regulates the activity, has begun to guide operations. And I think now the story has evolved to the point where it's well accepted.
Keranen and her student, Catherine Lambert, have set up equipment to detect extremely small quakes, hoping the small quakes might provide warnings of larger ones.
There's, in my mind, immense value to studying the earthquakes. I think there's a chance of solving problems we've been working on for decades. If we had an understanding of where big earthquakes happen, or even a few days or some number of hours of warning, we could prepare people, and we would basically be able to mitigate some degree of the hazard. It would be really a massive leap forward in safety. And I think these data give us a chance to do that. There's the economic impact of knowing where and when, but there's also the way to save people's lives.